In this video, we're going to take the data that we created in the design part of this tutorial. I'm going to show you how to assign toolpaths to it to create the part that you can see on the screen here. This is a very interesting decorative looking part, but in reality uses fairly simple toolpath techniques. Everything we're going to do here is either going to be a pocket toolpath, a profile toolpath, or a V-carving toolpath. How we're going to achieve the effects you can see of these different shapes is to go ahead and vary the type of tooling we use, and also to vary the depths that we're cutting to, and whether we're cutting on the inside, outside, or on the vectors that we've got selected. So let's go ahead and start a new copy of the software to begin. So let's click on the icon to open an existing file. From the project folder, we're going to load the data that we created in the vector drawing part of this tutorial. File's called quatrefoil panel vector.crv. I'm going to select that and hit open, and there we can see our design that we created. And if you've worked through that part of the tutorial, you'll know that we organized everything onto layers. So if I click the down arrow here for the layer manager, then what I can see is the 4 layers that we created our data on. For the first toolpath operation that we're going to create here, I'm going to pocket between the large circle and the inner shape of the quatrefoil. So I'm going to switch off some of the layers we don't need to make it easier to select and see what we're doing. So go onto the light bulb here for the first layer, outline shape. We'll click on that to make it invisible. We'll make the top and bottom groove layer invisible. We'll make the V-carve shape layer invisible. And I'm just going to click on the word foils to make that the active layer there, and go ahead and hit close. And the reason for doing that is just in case we went ahead and created any additional data. I don't expect to do that, but it's generally good practice if you've switched layers off and made your active layer currently invisible, that you change to a layer that's visible or that you're planning to work on. So let's go over to the Toolpaths tab. We can do that with this icon here, or we could hit F12 on the keyboard, and that will automatically close the Drawing tab and open the Toolpaths tab for us. Next, we want to set up our material, and that's always something you should do before you calculate any toolpaths. So we're going to come to the material setup area. We're going to click on the button that says Set. I'm going to check the values in here. Material Z0 set to the top of the block, which is fine. Thickness of my material is 1 inch, which is correct. I'm going to set the XY datum to be in the lower left corner for my machining. You'll notice there it was in the center for our design, but here I want to switch it to the lower left for the purposes of machining, so I'm going to click on that node here. We can see the datum's moved there. I can see in the 2D view the red square showing me that the datum's now in the lower left corner, so that'll be X0, Y0 when we come to set up our material and to set up our parameters for the machining on the CNC. Double check the rapid Z-gaps and the home position are both reasonable for the rest of our setup, and we can hit OK. As we work through our toolpath setup, it's important to remember that if you do plan to cut your own version of this part, that the choices you make in the toolpaths, including feeds, speeds, tooling, and all other parameters, are going to be safe and correct for your particular setup, machine, material, etc. So, as I mentioned before, the first toolpath I want to create here is just to pocket down some material between these outer circles. So I'm going to hold Shift down and select those 3 outer circles, and then still holding Shift, I'm going to select the inner offset of my quatrefoil shapes. So we now have those 6 vectors selected, and I come over and click on the icon to create a pocket toolpath. Start depth is going to be the top of the block, or 0, and the cut depth for these is going to be 1/8 of an inch, or 0.125. So we're just making quite shallow pockets here. I'm going to click Select on the tool database now, come over, and we're going to select the 1/4 inch end mill. We can double check the values within here to make sure we're happy with them, and go ahead and hit OK. Now I'm just going to choose a simple offset pattern here in order to clear these out. And don't think I need any other options, so we'll just put this pocket circles in this case, and then we're going to hit calculate, and there we can see our toolpaths that we've calculated there. If we want, we can change the material that we're previewing this in. We've automatically gone into the preview section after we calculated the toolpath there, and maybe we'll change this to be cherry. Now I'm going to check here. I'm going to uncheck the animate preview so that this just runs as fast as possible. I'm just really interested in the end result, and click on the button to preview selected toolpath. We can see there that's run through and just created 3 simple shallow pockets to hog out the top part of our material. If you wanted to make it a little more clear the area that you'd cut there, then you can always say that you want to use a toolpath color, and we could come in and choose something so that we can see the area that we've cut there if it's not immediately obvious to us. In this case, I'm just going to stick with the material color. Let's go ahead and close our preview toolpaths. And let's go back to the 2D view. In fact, what I'd like to do is see both the 2D and the 3D view at once. And I could go up to View and tile the windows horizontal, or you can see the shortcut key there is the page down button. So if I come into the 3D view here and on the keyboard I find the page down button, then that's going to display my 2D view at the top here and then horizontally orient my 3D view below it. So we can see everything that's going on now. Now the next thing that I'd like to do is just create a profile cut with the same tool on the inside of my circles to add this kind of detail groove in here. So the easiest way to do that is just to click in the white space to deselect the vectors, and then I'm just going to select the circle, hold shift down, and then click on the other 2 circles to select those. So again, just selecting these outer large circles here. I'm going to come over and click on the profile toolpath icon. In this case, we've already pocketed out 1/8 of an inch here, so I'm going to say that my start depth for this cut is 1/8 of an inch, and then I want to cut an additional 1/8 of an inch, so the overall cut depth for this toolpath will be 1/4 of an inch. It's a cumulative from the start depth plus the cut depth. I'm going to use the same tool that we've got selected here. I'm just going to click on Edit to check this. So with a 1/4 inch end mill, all the values look reasonable for this, so I'm going to hit OK. And in this case I want to cut on the inside of these lines that I've selected. So where it says machine vectors here, I'm going to choose the option for cutting inside, which means the tool will run round the inside edge of that vector. I don't need any of the advanced options in this case, so I'm going to say profile inner circles and go ahead and hit calculate. And again now we could say preview selected toolpath, and that's going to show me that we've just cut that additional groove in there to add some decoration to our part. So the next set of toolpaths we're going to create is going to use a large ball nose tool to add an internal scalloped edge around our quatrefoil and trifoil shapes. Main thing we need to be aware of here is that our trifoil shapes sit on the surface of the material, so they're effectively starting at Z0, whereas our quatrefoil shapes have to go down deep enough to allow for the fact that we've already pocketed out 1/8 of an inch, that they're going to effectively sit on that surface 1/8 of an inch lower. So that means we're going to need to calculate 2 separate toolpaths because of those different depth parameters, even though effectively they're going to use the same settings for each of the toolpaths other than that depth. So let's start with the trifoil shapes. I'm going to select the first one here, the first outer trifoil shape, and then hold shift and click on the other 3 to select those 4. And we're going to come over and click on the profile toolpath icon. In here, I'm going to have a start depth of 0 and a cut depth of 0.25, 1/4 of an inch. We're then going to go into the tool database. We're going to click the select button here, and what I need is a 1/2 inch ball nose tool. You can see we don't currently have one of those specified, so I'm going to add that. And an easy way to add it, if you know it's close to the parameters of another tool, is to make a copy and then to edit that copy. So if I click on the 1/4 inch ball nose, click on the button to copy, and then I might click on this first one in the list here, and we can edit the values. Now whenever you copy or add a tool, it's extremely important that the first thing you do is change the diameter and then change the name of the tool. and make sure that if you have tool size information in the name that it matches a diameter. You can see it's possible for me to change the diameter here to 1/2 inch, 0.5, but that doesn't necessarily update the tool name. So I need to make sure I come up here and update the tool name as well to ensure these two match and don't cause me any kind of confusion when I'm selecting this tool from a list and maybe I'm not checking the parameters. I'm going to come down, and the only other thing I'm going to change about this tool is the pass depth. This is quite a large tool, so I can go at least 1/4 inch at a time as we're cutting through the material. Everything else I'm just going to take from the defaults in this case, from the copy that we've made there. They all look like reasonable values. So let's go ahead and hit apply. That'll change the information in the list here. Then I can hit OK to select that tool. I'm going to make sure that machine vectors is set to cut on the inside. I'm going to run that around the inside of this vector here to create my scalloped edge, and I don't need any of the more advanced functions for this toolpath, and I'm just going to call that profile trifoil and go ahead and hit calculate. Now if we zoom in there, we can see our profile toolpath's been created. Can come over and click on preview selected toolpath so we can see what the effect of those toolpaths is going to be when we machine them. So there's our nice decorative scalloped edge on the inside of those shapes. Now we're going to do a very similar toolpath, this time on my quatrefoil vectors. So I'm going to select the outer one here, hold shift and click to select the same vectors for the other two quatrefoils. Now this time we need to be 1/8 inch lower because of this pocket we've already cut, but some material is still left here, so I don't want to put in a start depth of 1/8 inch because that may not be safe for the tool to go through this material that we've left in the middle. All I want to do really is make sure that my depth of cut is low enough that I account for that 1/8 inch and then go another 1/4 inch on from that. So I'm going to come over with those three vectors selected, click on the profile toolpath, say we're still going to start at 0 because I want to be at the top of the block to account for this area that we haven't cleared out with the pocket, but I do want to go 1/8 inch lower than this with my cut depth, so I'm going to put in a value of 0.375, so that's my 1/4 inch plus an additional 1/8. Almost all the other parameters in here should be correct because we just calculated a very similar toolpath. There's my 1/2 inch ball nose, cutting inside the vector. I'm going to call this profile quatrefoil and hit calculate, and then we can say preview selected toolpath, and there we can see that that's cutting down and machining the scallop into this pocketed surface here. So at this stage I have another toolpath I'd like to calculate that's also going to use the 1/2 inch ball nose tool. And typically it makes sense to keep groups of toolpaths together that do use the same tool, because you do have the option within the software to save those as a single file if that made sense for the way you wanted to cut the part. So in this case we could output all of the toolpaths that use this 1/2 inch ball nose as one file, and then the machine will just consecutively run those in whatever order we save them. So I need to use the layer manager now to get to a different layer, switch on the data I want to calculate this other toolpath on. So I'm going to hit F11 on the keyboard to come back over to the drawing tab. From the layer drop down list here I'm going to click, I'm going to switch off that foils layer, and I'm going to switch on the top and bottom groove layer and hit close. And you can see there that my layer name is red, which means that I have a layer that's currently invisible as my active layer, so that's always a warning sign. If I click the down arrow again, I can click on the top and bottom groove layer, make sure that's active, and that means I won't get any surprises if I start to create vectors with a layer being switched on because it was an active layer that was currently invisible. What I want to do here is cut each of these grooves with my ball nose tool to sort of run this scalloped shape along the top and the bottom. And I've drawn these actually at the width of the groove that I want to cut them. But really what it makes sense to do is for me just to run the tool down a single line here in order to create the effect that I'm looking for. So I'm actually going to sketch a couple of vectors just snapping to the midpoint of each end of these lines. Let's go ahead and just maximize the 2D view for a second, going to click on Draw Polyline, and I'm going to carefully get this icon here, so I'm snapping to the midpoint of the end of that rectangle and click, and then come to the midpoint of the end of this rectangle and click. Then I'm going to hit space on the space bar to accept that and create a new line, and again click on the midpoint there, click on the midpoint there, and then hit the right mouse button in order to accept those. Now at the moment, when I profile along these lines, it's going to drop the tool on there and machine along and lift up at the end. Now it might make sense to just ensure that these are going to come a little bit past the edge of my part to make sure there's no chance of me leaving any kind of internal scallop on there. So I'm going to select this line, shift and select this line here. I'm going to hit G on the keyboard to group those together, and then I'm going to come over and click on the icon to move, scale, rotate selection. That'll go into the transform mode. You can see I get the drag handles on here, and then holding the shift key down, so I'm scaling from the center of the vector, I'm going to click on the end and just drag this out a little bit so that I come out past the edge of those rectangles. So it may not be necessary, but it's just going to ensure that my tool is going to completely clear the edge of the part once we do the cutout pass. So now we can hit F12 on the keyboard to go back over to the Toolpaths tab again. Currently in the preview mode, so I can hit close here. I want to select that group of vectors, those two lines we've just created. Because it's a group, I just need to click on one of them and they'll be both selected. I'm going to come up and click on the icon for Profile Toolpath, and this time I want the start depth to be 0. I want the cut depth to be 1/4 of an inch. I'm going to use the same 1/2 inch ball nose tool, but this time I want the center of the tool to sit on that line and cut along it. So I'm going to click on the option to profile on the line. I'm going to call this profile top and bottom and hit calculate. And there we've got two simple line toolpaths running along our part there. We can say preview selected toolpaths. We can see how those two scallops are going to look on our part. So again, I'm happy with that. What I may want to do is go back to my tiled view, so I can hit page down on the keyboard to see the 2D view and the 3D view. We can hit close on the preview menu. So the next set of toolpaths is going to be to add some decorative V-carving into our part. So I'd like to go back to the layer manager to manage the vectors that I can see here and the ones that we're going to select for this toolpath. A good way to go straight to the layer manager is to use the shortcut key Control and L for layers on the keyboard here. If I click on that, that'll pop out the drawing tab with the layers tab automatically selected. Within here, I'm going to make that layer invisible. I'm going to switch on the V-carve shape layer and select that so that it becomes the active layer. And then I can hit F12 on the keyboard, which is the shortcut key to undisplay the drawing tab, or layers tab in this case, and to go back so we can just see the toolpaths tab on the right. So these vectors on this particular layer are going to be used to add some V-carve decoration to our part. Some of the vectors are going to be machined on the surface of the part at 0, and some of them are going to be machined into the area that we pocketed out. One useful feature to point out, if we zoom in here, at the bottom of the interface, just below where the cursor is at the moment, you can see there's an X, Y and Z coordinate being displayed, and that's showing me the position of the point of the cursor. As I move that over an area we've cut in the 3D view, it shows me the Z depth of that area. This is very useful if I wanted to eyeball, for instance, the area that we'd pocketed out and check its Z depth, and I can see there it's showing me a Z depth of -1/8 of an inch. So again, just a quick way of visually checking the depth of something. If you want to point the cursor at it, and then on the bottom of the interface there, it'll show you that coordinate of the area you're pointing at. So to help us with our organization, I'm going to group these vectors together in the groups for those that are going to be cut either at 0 or at -1/8 of an inch. You can see that something already appears to be selected in the 2D view, and that's because the object that we had on the layer that we switched off is still technically selected, so it's just showing me the handles there. If I just click in the grey area here, that's just going to deselect that, and we can go ahead and start picking our vectors and grouping them together. One thing to notice here is that my cursor is showing me that I'm still in the transform mode. Remember, the last operation we did was to stretch those two straight lines with our 2D editing. The four-way arrow next to the cursor here shows me I'm in the transform mode, and I really want to go back into regular selection mode before I start picking these vectors in order to group them. The best way to do that, or the quickest way to do that, is just to hit escape on the keyboard. Whenever you're in the transform or the node editing mode, hitting escape on the keyboard will go back to regular selection mode, and you can see that that four-way arrow has disappeared now, and I've just got my regular selection arrow. Now we can pick our vectors. I'm going to show you various ways that you can pick vectors from the 2D view. Most simple is just to click on an object. When you click on the line, it becomes selected. If I want to add to that selection, I hold the Shift key down, and then I can just simply click on any object that I want to add to the selection. Another way of selecting something is to drag a box around it. There's different behavior in the software depending whether I click from the top left and drag down to the right to make my selection box, or whether I click in the bottom right and drag up to the left to make my selection box. And I'll just give you an example of those. When we drag from the top left down, the selection box is only going to pick items that are completely enclosed within it. So if I click here and drag a box down to the right from the left, anything that's completely within the box will be selected. Anything that's partially in the box will not be selected. So if I let go of the mouse key, you can see only the four objects completely enclosed in the box were picked. If I drag from the right upwards, then it's going to select any item that I touch, so it doesn't need to be completely enclosed, it just needs to fall partly within the selection box. So if I click here and drag up to the left, then I don't need to completely enclose these, I just need to partially touch them. I can let go and they'll be added to that selection as well. So different situations might require you to use those different things depending what other vectors might be around the ones you're trying to select. It's good to understand those, and it's worth having a little practice to really get an understanding of what they do. Now I've got these vectors selected. To group them, I'm going to hit G on the keyboard, that's the shortcut key. Then what I can do is just click in the white space to deselect those. I'm going to click and drag a large box around everything here, and then holding Shift down, I'm just going to click on that group that we made before. Now because they're grouped, whenever I click on one of them, they'll all become selected or deselected. Now with these other objects selected, I can hit G and they'll become grouped together, and so either set of these vectors are now very easy for me to pick just by clicking on one item within those groups. So now let's calculate a V-carve toolpath. I'm going to select this group here first, and these are the ones that are going to cut on the surface at Z0. I'm going to come over, I'm going to click on the V-carve toolpath. Start depth is going to be 0. I don't want a flat depth. I do want a 90-degree tool. I can see that I have the correct tool selected here, so I'm just going to hit Edit. If you don't have the 90-degree tool selected, then hit Select and go into the tool database to get it. If I hit Edit here, I can check the values and make sure they all look reasonable. Hit OK, and then I'm going to call this V-carve surface and hit Calculate. So there's my toolpaths. If I want to zoom in, we can see how they look, and we could say Preview Selected Toolpath. So that's added some nice decoration on the surface there. Next, I'm going to close that. I'm going to select the other group here. I'm going to come into the V-carving. This time we're going to do exactly the same toolpath. The only thing I need to change is the fact that I'm machining on the surface of the pocket here. So I'm going to go with a start depth of 0.125. It's very important that I specify this, because for V-carving to work, it needs to know exactly where the surface is that you're V-carving into, so it can ensure that the tip of the tool is exiting or is coming up to that surface to create the nice angled edges. So we'll change the name of this, we'll call it V-carve pocket, go ahead and hit Calculate, and again we can preview those vectors, and we can see now that decoration has been added on the surface of the pocket there. Now just like with the ball nose tools toolpaths that we created here, we could output those two V-carve toolpaths as a single file so that the software will just run them, or the CNC will just run them cumulatively. So now we're almost finished. There's only one toolpath left to calculate, and that is our cutout toolpath. Let's go ahead and hit close on the preview toolpaths menu. So we're going to come back to the layer manager. So we'll hold Control down on the keyboard and hit L. And we need to switch off the V-carve layer. We're going to switch on the outline shape layer, and we're going to also switch on the foils layer so we can get the internal shapes that we need to cut out as well. Let's just click on the outline shape name to make that the active layer. Hit F12 on the keyboard to go back to our toolpath tab and to minimize the layers tab again. So we're going to select our outer vector, then holding Shift down, I'm going to select all the inner edges for our quatrefoil and trifoil shapes that we're going to cut out. I'm going to profile around these, so I'm going to come over and click on the profile toolpath option, and in this case we want to cut all the way through the material. So I'm going to put in a cut depth of 1 inch. I could also get that by hitting Z and equals sign on the keyboard, because that is the way of calculating the depth. If I can't remember the depth of material I've set, I want to be sure, I can just hit Z equals to get that value. And then select a tool from the tool database. I'm going to choose a 1/4 inch end mill, 0.25 inch end mill, apply, close, and I'm going to hit edit, and for this toolpath I'm just going to override the pass depth and tell it I want to go 1/4 inch at a time. So 0.25 and hit OK. I'm going to cut outside the vectors, even though in this case I want to cut outside the outer edge of my part, but I want to cut inside these inner shapes. Software will automatically do that. The only thing I need to indicate is which side I want to be on the outermost of the vectors that I have selected. So in this case I'm going to say cut outside the first vector that the software gets to, and then cut inside these vectors. Now the software also knows though that it needs to cut these inside shapes first and do the actual final cutout last. So all that is automatically calculated. So we've got start depth, cut depth, tool selected. We're going to cut outside the vectors. I'm going to say profile outside. I'm not going to use tabs in this case. We'll assume we've got a hold down mechanism for this that doesn't require me to use tabs to hold it in place. What I am going to do is add some leads to this though. What I would like the software to do is not plunge down right on the edge of my part. Maybe I want to be really careful with that edge quality so there's no kind of dwell mark or burn mark from the tool on it. So I'm going to come into the leads option here. I'm going to tell the software to add leads. I'm going to do circular leads, and we'll do a radius of 1 inch and a lead length of 0.5. And I'm also going to ask the software to do a lead out and put an overcut distance of 0.25. So what this means is the software is going to do an arc lead in, it's going to cut all the way around the part, and then it's going to do an arc lead out, but it's going to overcut, so it's going to cut past the original lead in by 1/4 inch. And this is all designed to try and minimize the tool plunging vertically down on the edge of my part as it enters the material. So let's go ahead and hit calculate. Now you can see there that the software has given me a warning, and if we read that, it says to avoid gouging, some of the leads had to be reduced in length or removed completely. And what that is probably means is that for these internal shapes here, there just isn't room to fit those leads in based on the parameters that I've entered here, so the software has automatically removed them. If they were essential to my part, then I would need to go ahead and try and find a set of leads that would work for it, or to edit my data. In this case, I'm really only concerned with a lead on the outside of the part. I'm not too worried about these internal shapes. And so as long as I've got the lead on the outside, then I'm not going to worry about this. So if we hit OK, we can take a look at this. I'm going to maximize the 3D view, and we can see our cutout pass there. And if we look at our part here, we can see this lead in and lead out. So it's leading in, going round the part, coming round here, then leading out again. Now it may be that I don't want it in this corner position. I might want to be more specific about where that lead's going to be. And what I need to do is look at editing the start point for my vector where we're doing this, where we're calculating this toolpath. So to change the start point for our toolpath, I need to change the start point for the vector. That's what the software is using to calculate this position here. So I need to go into the 2D view, which I could do by clicking on the tab here, or it's a shortcut key to do that is F2 on the keyboard, the function key F2. To go between 2D and 3D view, F2 goes to the 2D view, F3 goes to the 3D view, and just makes that the main window. Here we can see the vectors are selected for the last toolpath we calculated, plus I have the 2D preview for that toolpath. So I'm just going to click on the checkbox here to undraw that, make it a little easier to see my vectors. I'm going to click in the white space away from the vectors to deselect everything, and then just click and select my outer vector. Node editing is accessed by hitting N on the keyboard, at least the shortcut key for that. So I'm going to hit N. And what I would like to do is change my start point from its current position, which is indicated by this green node here, to be halfway along this side. Easiest way to do that would be to insert a point here. So I'm just going to click and drag to select my virtual midpoint there, right mouse click and say insert a point, or I. And then what I can do is change that to be the start point, and the shortcut key to do that for hover over the node is P on the keyboard to change that to start point. So that now is my new start point for this vector. So I'm going to go and hit the page down key on the keyboard to tile the windows 2D and 3D horizontally here, and I want to edit this toolpath. I could do that either by clicking on the edit toolpath icon here, or I can double click the toolpath. That'll open it up. It will automatically select the vectors that I had selected before, and I should just need to hit the calculate button for it to recalculate that toolpath. Again, it's going to give me a warning message because it's removing or shortening some of the lead in and lead outs inside of the part here. But if I hit OK and we just maximize the 3D view and take a look at this, now we can see that that has moved my lead in and lead outs. It's moved the start and end position of the outside of the toolpath to that node that we inserted and changed to be the start point for our vector. Now we could go ahead and preview this toolpath. So we're in the preview, automatically went into the preview here. With that selected, what I may want to do is just check that it is going to cut all my interior vectors first. So the way I can do that is just say I can run to the next retract here. So if I click on that, I can see there that it's cutting each of the layers there, then it's going to cut the next one, so it's showing me the 4 depths of cut for each of those. So it's going to cut out all those internal shapes first, and then finally we're going to go and do the external cut. So there we can see the lead in and lead out there, and there it's cut all the way through the part. Now at this point we might want to really visualize exactly how the part's going to look when it's cut out and finished. So we could remove the waste material, and we do that just by clicking or double clicking on any of the pieces we'd like to remove. So if I come over here and double click on these interior pieces, we're going to remove those. So just a double click on each of those, a double click on the outside, and there we can see our finished preview of all those toolpaths that we've calculated for this part. Now if we wanted to, we could save this image, come down, click on Save Preview Image. We could save that, bitmap, JPEG, one of the other file formats there, email that to a customer for approval, or use it for promotional material to kind of show on your website the type of parts that you can cut. So lots of different options there. Really nice to be able to get such a clear preview of the part as it's going to be machined, and to be able to carefully check everything to make sure everything looks right. Now once we're happy with this, once we're happy with the preview and we're ready to save the toolpaths and run them on the CNC, we can close this preview window here. What I need to do is carefully select my toolpaths so I can output them. In this case it would just need to be 4 separate toolpaths. I'd have one toolpath to pocket the circles and profile the circles with a 1/4" end mill, then one toolpath with all the 1/2" ball nose, one toolpath for the V carving, and then finally my cutout pass. So in order to output these as a single toolpath, what I would do is click on Save Toolpaths. I would choose my appropriate post processor for my machine, and I'll click the checkbox here to output all visible toolpaths to one file. At the moment I have no visible toolpaths. Toolpaths are made visible by me checking the box next to them. So now with this set I could come in and click them in the order that I want them to be saved into the particular file. So for the first two here I'd click the first one, then click the second one, and so the software shows me now those two are visible, that it's going to save. When I hit Save Toolpath, it's going to save a single toolpath. The first part of that toolpath will do the pocket circles, the second part of that toolpath will profile the inner circles. I'll just click on Save Toolpath, give that a name, and then that's going to be the toolpath I'm going to run with the 1/4" end mill. To save the next toolpath, I'd uncheck the visibility of those, and then I would carefully check in the order that I wanted them to be run within the single file the next three. So in this case I would click on Profile Trifoil, Profile Quatrefoil, Profile Top and Bottom. Once more, those are then in that order, and when I click Save they'd give me a single file that contained all three of those toolpaths because they're all using the same tool, and I would be able to save that. And lastly, I would come down and we'd do it with the V-carve. So I'd choose the V-carve surface and the V-carve pocket. Again, we'd save that as a single file to cut with that V-carve toolpath. Then finally, the profile outside to save that last. So that pretty much completes everything that I'd like to show you in this example. I'm going to save the file, Save As, and we'll save that in the project folder. We'll call it Quatrefoil Panel TP, show there are toolpaths in this file. Go ahead and hit Save. So if you wanted to, you could open that, take a look at everything that we did within this particular example here. Let's just take a second to summarize some of the many things that we've looked at in this video. If you remember, we started by opening the set of vectors that we created in the companion tutorial to this, where we showed you how to lay out the design. We then carefully worked our way through using the layers to help us more easily select the vectors that we wanted for different toolpaths, and calculated each of the toolpaths using different tool geometry and different styles of toolpath to create all the effects we wanted for our part. We started with just some simple pocketing and profiling with an end mill in order to calculate the area and just pocket this area down here for each of our circles. Then we calculated the profile toolpath using a large ball nose tool to add the scalloped edges to the insides of our trifoils and our quatrefoils. One key thing that we looked at there was how we needed to use different toolpaths for the different depths of cut that we wanted to use, even though ultimately we might end up saving those as a single file to send to the CNC. So the first set we calculated were on the surface at 0 for the trifoils. The second set we calculated need to go 1/8 of an inch deeper to allow for the fact that we'd pocketed out this inner surface here. Then we looked at profiling the top and the bottom. We drew an individual line to make that toolpath as efficient as possible, stretched the line a little to ensure that that tool was going to come past the edge of our part when we cut it out. Then we went ahead and calculated our V-carving, and again we needed to do that in two separate toolpaths, one on the surface and one 1/8 of an inch lower to allow for the surface of our pocket here. Then finally we looked at profiling and cutting out the part. In there we saw how we can add things like a lead in and lead out to help the edge quality around the outside of the part, how the software will automatically remove those leads if it hasn't got the space to fit them correctly, and also how we were able to change the start point of the vector and move the position that the tool was entering the material and leading in and out of that profile cut. So that concludes what is a reasonably complex example, but hopefully has given you a really good idea of just what you can do with the software with relatively simple shapes with regard to the layout and the design, as well as with relatively simple toolpaths, but just using them in combinations with each other and using them with different tool geometries and effects.